the majority of the problems we're going to have to solve algebraically in this unit will be sort of one of two types of problems. So it'll be something like this, and it'll ask us to find the limit as x approaches 2. Algebraically, all we're going to do, let's actually start with a simpler example. Let's change the denominator to x squared plus 2x. Right now, this function is defined as x approaches 2. So if you were asked a question like this, let's just put in 2, and you get 4 plus 8 minus 12, and the denominator we get 4 plus 4. So this is just equal to 0 over 8, which means the limit is 0. Because the function's defined as x approaches to, or as at 2, the function's 0. If we looked at a graph, there's no problem. There's no holes, nothing like that. But if we go back to my original example, and I change this back to a minus 2x. Now, can you see what would happen if we put in 2? The numerator, same thing, 4 plus 4 is 8 minus 12 is 0. The denominator, if I put in 2 squared is 4, minus 2 times 2 is 4. See how it'd be 0 over 0? What's 0 over 0? It's not 0, right? If anything, it'd be undefined. But we have to be careful. Anytime this happens, this is called an indeterminate form. We're going to learn more about this later in the year. But anytime we have something like this, it means our work isn't done. It means the function isn't defined at 2. But is it possible that this limit does exist as x approaches 2? Because remember we talked in the last video what that means. It means from the left and from the right it equals the same thing. So here's how we're going to treat, basically this is our only real option for problems like this. We're just going to factor. So if we factor this function, x squared plus 4x minus 12, that's going to be x plus 6 times x minus 2. And the denominator we can factor out an x, and we're left with x minus 2. Now we can cancel the x minus 2 on the top and the x minus 2 on the bottom, and we're left with x plus 6 divided by x. Now if we put in 2, that's equal to 8 over 2, which equals 4. So we do have a limit. As x approaches 2, that means the graph approaches 4. I'm not going to show you the graph right now, but if you want to graph this on your own, what you're going to find out is there is just a hole at 2 comma 4. That point doesn't exist, again, because if you put in 2, that makes 0 over 0. So the function isn't defined at 2, but it's just a hole. From the left, it approaches 4, and from the right, it approaches 4. So this is going to be our main tool in this unit, algebraically, how to find limits.